Hi, welcome to my channel, JaberTime. Today I'm going to go over functions of several variables. As you can see, I have enough graphs in 3 dimension. Let's get started. Functions of several variables. As you can see, we have a domain here, D, and we have a range. The domain is going to be r to the second, the xy plane, and the range will take you up to the z values. AB will take you to f of AB, and xy will take you to f of xy, and that will be up on the z-axis. Of course, like it could be down, but that's what we have. A function f of two variables is a rule that assigns to each ordered pair of real numbers x and y in the domain D a unique real number f of x, y. So the domain is consisting of the points x, y. The range will consist of the outputs f of x, y, which is over here. That's going to be the range. Here's an example. It says find the domain of this function, evaluate the function at 3 and 2, and graph the domain. Notice that the green part right here has to be greater than or equal to 0. It's inside the square root, and it's on the numerator. In the denominator, I have it in blue, x minus 1. I can't have x equals 0, x equals 1, because that's going to force the denominator to be 0. So those are conditions that are given to us. Now think about this one as an equal sign for now, which is called borderline. If x plus y plus 1 equals 0, that means x plus y equals negative 1. That's a straight line. The x-intercept, if you want to graph it, it's negative 1, 0 when you put 0 for y. And the y-intercept, when you put 0 for x, you get minus 1. If you plug in 3 and 2, straightforward, that's what I have. Now I think this one says enough about the domain, these two, but let's, with that, graph it. So you are walking on the line also with the equal sign. This is the line that I was referring to, the x-intercept and the y-intercept. Because we have an equality sign with equal, so it's a solid line. And if you get tested this side or this side, if you plug in 0, 0, you get this as true, which means this is my side, but I can't be at x equals 1, so this has to be dashed and marked. Everything here, including this borderline, and take this line out of your domain, and that's your domain. Interesting, right? Let's take another one. Find the domain of this function x multiplied by ln y to the second minus x, and graph the domain. Well, this is my function. I'm using green here because I want you to pay attention to this and focus with me. I'm trying to save you some time, as you could see, guys. I take more time building the notes and focusing on the notes to make it a little bit faster recording instead of recording 45 minutes. I'm trying. Well, because of the len and log functions, the domain has to be greater than 0 to the right side of the y-axis. Simplifying this, that says y squared is greater than x. But with greater than, that's a little bit confusing for some students, and they are switching things around here. Usually we say y and x squared, not x and y squared. So let's switch it back the other way. X is less than y to the second, which is equivalent to this. Now think about if it's equal, just to get the borderline. Well, it's a parabola, but it's not opening up, it's opening right. And because I don't have an equal sign right here, it's dashed, so it's not mine. Test it right side and left side, you will see that you are on the left. This does not give me any conditions, so I left it alone. and you want, here's another way to see the concept. Instead of plugging points to see which side is yours, x has to be less than y to the second. If you move left side, x has to be less than. Here, x is equal to y to the second as you walk on this. Going this way, x is going to be less than. Let's take another example. Domain and range of this function. The domain will be xy such that what's inside has to be greater than or equal to 0 because we are inside the square root. Differently, that means if you move this side, that's going to be x squared plus y squared less than or equal to 9, reading it the other way around, or rearranging it, it's x squared plus y squared less than or equal to 9. And the range is just the outputs, z square root of 9 minus x squared minus y squared in the meantime. But notice that the range is the square root. That means the principal square root. That means positive. So the z-scores or the range has to be positive. Greater than or equal to 0, because if this is 0, if this adds up to 9, that's going to make it 0 also. 9 minus 9 is 0. Now notice, which is interesting right here, that 9 minus x squared minus y squared is not going to exceed 9. Anything you put here, that's going to reduce the value that you have. It's 9 minus something. You always kind of like having 9 and you're taking something out of it, deducting some amounts out of 9. So two things. Z has to be greater than or equal to 0, and this part right here inside has to be less than or equal to 9, which means the square root has to be less than or equal to 3. So with these two, that's my z, by the way, the range is between 0 and 3, including 0 and including 3. Here's the graph. The domain is x squared plus y squared less than or equal to 9, so it's a disk, it's not a circle. Everything inside and the boundary line. The range, everything from here with this function will give you some outputs, z values. That's kind of like a z. All the time you're going to go up to between 0 and 3, and that's it. Including, of course, you see those are brackets, 0 and 3. I think that explains it all. If you notice this right here, there is a lot of things you could talk about, but I'll just keep it this way. That's a behavior of a circle, but because of inequality, you have the included part. Okay, let's move on. So here's my domain, lives down in the xy plane, and this is a surface. You could see it's kind of tilted, right? This is xy0 because there is no value for z, and up here it will be xy and the output that he came up with. So this much right here is the z value. If f is a function of two variables with the domain D, this right here, then the graph of f is the set of all points xyz in R to the third. xyz, those are xyz. Out in space, R to the third. Such that z is, that's my z, f of xy, and xy without the z in it is in the domain. It belongs to the xy plane. The graph of the function f of the variables, of the two variables, is a surface S. This is a surface with the equation the equation of this is z equals f of x, y. Sketch the graph of the function fxy equals 6 minus 3x minus 2y. This is my function. I'm going to call it z for the convenience, but that's a plane. For some reason, sometimes students, they mix up between equations of planes and lines. This is a plane, linear in x and y and z. Rearranging 3x plus 2y plus z equals 6 to support that this is a plane. Also, it's going to help to see it that way. To graph it, because they want me to sketch, this is a simple graph, but it's very handy to practice for higher level and different ones. To find the x-intercept, you just put y equals 0 and z equals 0. 3x equals 6, that means x equals 2. That's my x-intercept. You can see I'm reducing the calculations because I want to save you some time. I want to get to the point. Here's the y-intercept, same process. 2y equals 6, that means y equals 3. Here's the z-intercept. X and y will be 0. That means z by itself is 6. And here's the graph. It intersects the x at 2. It intersects the y at 3. And intersects the z-axis at 6. This is a plane, but we are seeing it from only one point of view, which is the first octant. Of course, it extends and keeps moving on. Sketch the graph of this function. So you're going back and forth, guys. It's the same math, but from different angles. How do you graph this? Well, notice that we talked about that z has to be greater than or equal to 0. That's my z. Square both sides. I just need to know what's happening with the graph so I could see what type of graph is it. Is it a box? Is it a square? Is it a parabola? Is it a plane? Is it a straight line? So by moving around things, as you could see, I have x squared plus y squared plus z squared equals 9. That's not a plane. It's not linear in x, y, z. It's a sphere with center 0, 0, 0, the origin, and radius of 3, because this is r squared. And z will go from 0 to 3. Why from 0 to 3? Because we said that this is positive, and we talked about that earlier. So how does the graph looks like? It's a sphere, but sitting on the floor, the xy plane, including the plane xy, all the way up to 3. So it's the top half of the sphere, including the surface of it and including the bottom side. Intersects at 3 here, intersects at 3 here, goes up to 3, and this is kind of like the projection down as a circle. All right? Okay. So far, good progress. So let's move on. Find the domain and range and sketch the graph of h of xy equals 4x squared plus y squared. So here's my function. The domain is all real numbers in 2 dimensions. I could have anything for x, I could have anything for y. So pretty much the whole xy plane. The range is including 0, from 0 to infinity, because it can't be negative as an output. Here's the graph. And we call it elliptic paraboloid. It's a parabola in 3 dimensions. But I want to add to it one more. Notice that this is your function. In the xz plane, if y is gone, it's vanished. You're just like looking at the z and the x plane. You see it this way. Look, it goes up fast, so it's narrow, steep. On the yz plane, there is no x. Looking at it from one angle, from one point of view, it's normal opening or wider compared to this. As you could see, going this way it's narrow, going this way it's wide. So it's not like the same opening anywhere you go. It's narrow with the X, wider with the Y. Level curves. What's level curves? The level curves of a function f of two variables are the curves with equations being constant. K is constant. F of xy is k, where k is a constant. So our equation or graph, if you cut it or mark it at the same distances, let's say you go like 1, 2, 3, 4, 5, or 5, 10, 15, so equal increments. What happens is, if you drop these down on the floor, it's called contour map. These are close compared to this. Why? Because when this goes down, and this is not far away from it as radius. So when you have on the contour map lines are close, that means the original graph in 3D is steep. That's the meaning. Sketch the level curves of the function f of xy equals 6 minus 3x minus 2y. For the values of the function, as k is negative 6, 0, 6, and 12. This is going to be our last example, and it's kind of straightforward. It's just like lines, not curves. So this is our function, which is a plane. When k equals 6 minus 3x minus 2y, you put k for z, then I'm going to use these numbers. Reducing that or rewriting it, I could write the x's and y's on the left, and I'll put k next to x as 6 minus k. That's one option, just to see it's a straight line. When x equals minus 6 here, 6 minus negative 6 will be 12. I have the answers for you. Trying to save you some time. Here's the graphs. Those are the contour map, because we are graphing on the xy plane. I'm using this as in green to highlight and talk about it. 3x plus 2y plus k minus 6, because it's on the left, it's going to be k minus 6. When k equals negative 6, that's minus 12. Rearrange and make it slope intercept form if you want to. It's a slope of negative 1.5 and a y-intercept of 6. 12 over 2, which is 6, looks like a b. All these will be the same slope. These are the same slope, as you could see. 3x plus 2y, 3x plus 2y. They have the same slope. And here's my last comment for this section. The level curves are equally spaced because we are going negative 6, 0, 6, 12. Of course, these are also spaced. Are equally spaced parallel lines because the graph of f is a plane. It's not going up and down, steeper in some places like mountains and so on. So it's just like a plane. So when you carry it or mark it with level curves and drop those level curves down on the xy plane as a contour map, it's going to be equal distance lines like these guys, parallel lines with the same distance. Okay, that should do it. And I tried my best not to make it too long, and hopefully you got the content clear. Thank you, and I'll see you next time. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.